Hello everyone. Today I would like to address a number of questions that people have asked me and also reflect a little bit on where we stand today with the pandemic, as well as to give you a perspective on what I think should be maybe the next step. Okay, first of all, first question that or one of the questions I am receiving quite frequently is people ask me whether vaccinated people can transmit the virus. So my response to that question is yes, definitely vaccinated people can transmit the virus, especially when they are infected with variants. It is very clear that when they are vaccinated, the infectious load will be diminished, so they will shed definitely only a few quantities, little quantities of virus, but they can be qualified, so to say, as asymptomatic shedders, because the vaccines do not prevent against infection. They do prevent disease, so they do protect against disease, but not against infection. So how long these people can shed, I don't know. We know that asymptomatic carriers shed only for a few days. When people are vaccinated, infected with variants and shed the virus, I'm not aware of any studies that have investigated how long people are shedding the virus, how long vaccinated people are shedding virus. Second question, how come you say the vaccines are efficacious but not adequate for mass vaccination? Well, this depends on how you look at those things, whether you look short term and at an individual basis, or whether you look in the longer term and at the population level. So for sure, the current vaccines do protect against severe disease, and even if you have variants and highly infectious variants, most of these vaccines will still reasonably protect against severe disease. So yes, these vaccines are efficacious and to a large extent still efficacious against variants in terms of protection against severe disease. So on the other hand, if you look at the longer term and at the population level, it is clear that a virus will always try to adapt to the population in order to survive. So now when you vaccinate people, so especially if you do mass vaccination campaigns, you will be vaccinating an increasing amount of people. So a substantial amount of the population ultimately will consist of vaccinated people. And so vaccinated people are people who mount immune pressure against the virus. We know that the vaccines essentially generate antibodies against S protein, so that protein is responsible for infection. So this immune pressure that is mounted is not always sufficient, because when people are vaccinated, when they are in the process of seroconverting, when they are waiting, for example, for a second dose of the vaccine, when the vaccine gets delayed, the second dose gets delayed, or when vaccinated people are encountering variants, highly infectious variants, so mutants, escape mutants, for example, the immune response will be, of course, less efficient, so will be suboptimal. On top, there are also a substantial amount of people, about 80% of the population, that will still, non-vaccinated, that will still be infected in an asymptomatic way. So that means that these people will not develop the disease, but they will, or a certain amount of them, a substantial amount of them, will develop antibodies, but those antibodies are only short-lived and they are suboptimal. So yes, in a vaccinated population, when we proceed with mass vaccination, we have a substantial amount of people who are mounting a suboptimal immune pressure against S protein that is responsible for infection. So now what the virus will do in that population is the virus will start to select variants that are able to overcome the suboptimal immune pressure. And by selecting variants that are capable of overcoming this suboptimal immune pressure, virus can spread multiple times under these conditions, and by doing so it will ultimately adapt to these harsh conditions that are prevailing in a substantial amount of people within the population. And this is to say that in fact this virus will have an evolutionary advantage and will have a higher capacity to replicate. So that is how ultimately the virus can even become, or these variants can even become dominant and ultimately even resist the vaccine. So the other important thing is, well, one could say, okay, if that occurs, we make another vaccine, for example, but in the meantime there is a problem, because even people who do develop antibodies against these variants, very often these antibodies can no longer, or at least some of these antibodies can no longer neutralize the virus, but they can still bind to the virus. And that is something which is, at least according to my understanding, not a favorable condition, because antibodies that bind but can no longer neutralize the virus have still an affinity for the virus that is higher than the affinity of the natural antibodies. And so they can suppress the natural immunity, natural antibodies. And we will come to that later on, but that is not a very favorable conditions, as it weakens the immune response, especially to coronavirus non-specific variants. Okay, so then some people say, well, it's impossible that a virus can resist the vaccine, because it would need to resist or to overcome all immune responses mounted to the virus. And that is certainly not true, because we know that the coronavirus and the SARS-CoV-2 virus can easily be transmitted even before the cytolytic or cellular immune responses kick in. So that is to say that when the virus gets into the epithelial cell of the upper respiratory tract, it can within a very short period start to replicate, and then it will be shed, it will be spread, it will be transmitted, and that is before cytolytic responses, for example, cytolytic T cells kick in. On top, with regard to resistance to vaccines, etc., this discussion of resistance to cellular immunity is a little bit obsolete, in a sense that, as far as I'm aware, none of the current vaccines do induce virus-specific cytolytic responses that are able to kill the virus in all vaccinees, for example. And by the way, these responses are MHC class 1 restricted. But as the vaccines do not induce this type of immune responses, I mean, this discussion about resistance of the vaccine, resistance of the virus to the vaccine based on resistance to cellular immune responses is not in fact applicable. So I guess what I'm saying is that to some extent mass vaccination leads to a kind of immune compromised status in a large amount of vaccinees, and taken together with the asymptomatically infected people, who a lot of them or many of them develop suboptimal immune responses anyway, you end up indeed with a number of kind of immunocompromised people. It's very well understood that immunocompromised people, immunocompromised due, for example, to genetic defects, they can, they are prone, in fact, to developing immune escape variants. So if that is generally acknowledged, is of course no reason to believe that people who are kind of immune compromised because they are endowed with suboptimal immune responses would not promote or would not favor the development of immune escape variants. The only difference probably is that the immune pressure exerted by vaccine-mediated antibodies is very selective. It's selected against the S protein that is responsible for infectivity. So another question is, can success of vaccines be increased if combined with infection prevention measures or if those vaccines are updated? Well, I think I have explained a number of times that according to my understanding, infection prevention measures in their own right, especially if they are implemented at large scale, can in their own right lead to the development and propagation of immune escape variants. And the reason why I'm saying this is that we have seen that before mass vaccination, in October, November, all of a sudden a number of variants were seen in the population and were circulated. And the mutations that were found in those variants, they basically all converged to domains in the S protein that are responsible for binding to the receptor, to the AC2 receptor of susceptible cells. So normally the asymptomatic carriers, as I was saying, when they are infected, when they are exposed, a number of them will develop suboptimal immune responses. When during that time, during these long-lived antibody titers, they get infected with the virus, their immune response can be suppressed. So it is remarkable that these escape mutants were seen after many, many months, in fact, because initially the infectivity rates were pretty low in the population. In October, November, the infectivity rates in the population started to grow, and this could explain why these mutants emerged, well, not emerged, but why they started to develop, as the frequency or the likelihood that people who got asymptomatically infected and had these short-lived antibody responses and were to some extent due to these antibody responses, suboptimal antibody responses, immune suppressed, got in contact with the virus was increasing because of the increasing infectivity rate. So this could have led to a selection of immune escape variants that did exactly the opposite of what we were doing. We were trying to prevent infection, and those immune escape variants were showing a higher level of infectiousness. So I don't think that combining mass vaccination with infection prevention measures will give us a better chance to avoid this phenomenon and to be better armed to restrict or to suppress the further development of new highly infectious variants. So the second question, can we update the vaccines? I don't think this will help personally, because remember, if we vaccinate people today and we have to vaccinate them, let's say, with a new vaccine of the same type, but it could even be a multivalent vaccine in let's say half a year or a year from now, the first thing that will happen is that antibodies will be recalled, the memory will be recalled from the first vaccination. And this memory will, as far as antibodies are concerned, consist, of course, of antibodies that were initiated or that were elicited by the first vaccine. The S protein of which was different or is different from those of the variants. So if we inject a vaccine like in a year from now, the likelihood, of course, that the antibodies that will be recalled, the original antibodies, will differ or will not match with the S protein of the new variants that meanwhile have developed, because, I mean, they develop further. The coronavirus COVID has a replication cycle of about 10 hours. It will not wait till we come with the new vaccines. So the match will be even worse. It will be a mismatch, and that will even further promote immune escape, in a sense that the conditions of an antibodies that to a large extent mismatches the antigen is of course suboptimal, and will further promote the development of immune escape variants. So another question is, why are waves so different from one country to another, and how many waves are we going to see before the pandemic comes to an end? Well, to the first question, why are waves so different from one country to another? Of course, in different countries, the demographics and also the social economic status of people is very, very different. So that is with regard to the population. Also with regard to the virus, we have different variants circulating, of course, in different countries. So that is on the virus side. And then we have several different influences of human intervention. So, for example, the infection prevention measures and containment measures, etc., the strategies and the way those are implemented may be slightly different from one country to the other. So there is a number of factors that, of course, will shape and will modulate the dynamics of the infection, the dynamics of the pandemic, and that is why also the curves look very, very different. But there is another factor that I think is very important, which is I personally think that it is very important to distinguish between the time point of mass vaccination. At which point during the pandemic do you, for example, induce this, or do you start this mass vaccination? Do you implement this mass vaccination? I think if, for example, you start mass vaccination campaigns during the peak, so where there is a high burst of infectivity, it's of course not surprising that by implementing a mass vaccination campaign, you will strongly diminish that infection pressure, and you will bring down the peak depending on the speed of the mass vaccination campaign. You can do this pretty rapidly, and I will show you an example just in a minute, how the rapid implementation of mass vaccination campaigns can reduce the infectivity rate quite rapidly and quite dramatically. However, we see that between peaks you have a kind of transition period, a kind of quiescent period that demarcates, in fact, the transition from one population to another. So you have the first wave, where you have, for example, people who are vulnerable in some countries. These are especially people, for example, living in slums or in favelas, for example, in Brazil. In other countries, these are primarily the elderly people, for example, most likely due to their weaker innate immune system. And but then after a while, after a kind of quiescent period, the virus will attack people who were in fact protected during the first wave. So when you now implement a mass vaccination campaign, not during the peak, but during this transition period, then the effect may be quite different. The reason I'm saying this is that when you vaccinate the people during this transition period, they will primarily serve as viral shedders. So their impact on reducing the the total peak of infectivity will of course be less pronounced because you're already at a pretty low level. But at that point where the infection starts in the part of the population that was protected during the first wave and who as a result of the first wave may still have short-lived antibodies, well, if you now come with lots and lots of asymptomatic shedders, people being vaccinated basically, the likelihood that you will now infect those people who were initially protected and have short-lived antibodies, that you will infect them during this short period of that they have antibodies, will become increasingly higher because you're adding a lot of vaccinated, of asymptomatic shedders, and these people will of course increase by their shedding the likelihood that somebody with a short-lived antibody titer will get infected during that very period. And that is where I'm saying that these antibodies that are suboptimal, not functional, may suppress the natural antibodies that were responsible for protecting these people during the first wave. If you lose that protection, your vaccination of people, of elderly, for example, may lead to enhanced susceptibility of that population that was protected during the first wave. And so you would have the opposite effect. Vaccinating during this quiescent period could lead to enhanced, in fact, and accelerated infectivity. So I'm showing, for example, here, I hope you can see this. This is a comparison between the United Kingdom and Chile. For example, they started vaccinating around the same period, somewhere in December last year. And so you see the yellow zone here is indicating well, when mass vaccination got really implemented. It's not the very start, it's after a few weeks, of course. And here you can see that this time point coincides with a high peak or with a high infectious load in the population, high infectivity rate. And it had a dramatic effect, so the infection diminished quite rapidly and dramatically. Whereas in Chile, for example, the mass vaccination also implemented or rolled out in December last year started during a period of relative viral pandemic quiescence, I would say. And you can see that there the trend is exactly the opposite. As vaccination was progressing, you saw an increase in the number of cases, and as far as I'm aware, this is still going on. So, of course, some people may say, well, no, that the reason is because you are still not sufficiently vaccinated. But as you will see, as one will appreciate, also in Chile, for example, vaccination rates are increasing, but still you have this completely opposite trend as compared to the UK. So I am also showing here another example, which is, for example, the example of my country, of Belgium, where you see we have also started vaccinating in January of this year, and so once the vaccination was in fact implemented or started to be implemented, we had a plateau, and now with increasing vaccination, but all other conditions are in fact the same because we still have all the infection prevention measures and containment measures, etc. We all of a sudden started to see an increase in cases, and as I was saying, there was a kind of shift to the population that was protected during the previous wave, as now we are seeing cases, several cases or an increasing amount of cases in people of a younger age group. So it seems like here also vaccination seems to lead to an increased rate of infection in younger people. So the worst case would be, of course, if you, according to this principle, if you would vaccinate during this quiescent period in the presence of highly infectious strains. So if you have highly infectious strains, and of course I forgot to tell this, if you see, for example, situations like in the UK, where you all of a sudden you have a peak, and then this peak, it was clearly due to the UK variant, which is much more infectious and started spreading much more massively. So if that happens, of course, all of a sudden you will have a peak, and it may even to some extent abolish the effect of the vaccination. But the worst case normally, I think, is to start a mass vaccination campaign during this quiescent period, where in the presence of highly infectious variants, because of the highly infectious variants, the likelihood that people who have been previously protected, but as a result of the first infection, are still sitting on their short-lived antibodies and suboptimal antibodies becomes, of course, higher. And if on top you add then to that population lots and lots of vaccinated people who become in fact asymptomatic shedders, especially in view of the fact that there are highly infectious strains circulating, so their antibodies match less well with the S protein of the variant. And that is certainly a situation where I think your vaccination will have exactly the opposite effect, and you may and it may drive an increase in the number of cases. So as a matter of fact, today the waves seem to be completely unpredictable, and epidemiologists are not longer able to make a reasonable forecast. They are looking at these waves and at these curves like at exchange rates on the stock market. I mean, there is no prediction made anymore. Curves and shapes of these curves are all over the place. And I think that is really a problem, because it seems that this is also illustrating that to some extent this pandemic is out of control. So what are we going to see in future? So that was the other question, how many waves are we going to see before a pandemic comes to an end? Well, what worries me enormously is the fact that these platforms, even for example in countries like in Israel, they are not, of course, reaching zero. There is only one platform, one type of platform that is acceptable. That is a platform that is situated at the level 0. And the plateaus that we see right now, even in the very best case, they still indicate infectious rates that are about at least 10, 20 times higher than the plateaus that we had before. So this means that there is still transmission ongoing, and even if this infectivity rate is pretty low, it is still sufficient. It is still sufficient to ensure further transmission in a population that is increasingly vaccinated, in people that have been asymptomatically infected. So in a whole population that is exposed or is endowed, I would say, with suboptimal immunity. People getting vaccinated, people having been asymptomatically infected, and so the vaccinees waiting for a second dose, or mounting their antibodies, or being or encountering a virus, the S protein of which is pretty different from what was in the vaccine. So this then becomes really, because situations or immune status of people in that population where the infection is currently ongoing is pretty similar, in a sense that it is to a large extent suboptimal. Well, this plateau then become really a breeding ground for immune escape variants. And I think what we are going to see is not only, like for example in Belgium, that from time to time when the infection rate increases, that you will see a surge. But if this is really a breeding ground for variants, all of a sudden you will notice, or you will see, that the virus becomes resistant to the vaccine, and then all of a sudden you will have, like you see when an infectious variant is imported in the country, it can also immediately result from the fact that you have this breeding of infectious variants in your country within this particular population, and when these variants then become resistant, you will all of a sudden, of course, see a large peak, and that is what I think, I don't hope it, but I think is even going to happen in countries like Israel and the UK, that ultimately, if you don't have a platform that goes to zero, activity is still going on. These people, you know, who are transmitting, etc., when they become increasingly vaccinated, they're a breeding ground for these immune escape variants, and you will all of a sudden see that you have a steep incline because you get a resistant, the variant becomes resistant to the vaccine. So people say this cannot be, because this has not happened before. Well, I'm always thinking of this man staring at a volcano who says, well, you know, it will not go off because it has not erupted before. And the situation here is, I would say, even worse, because we are really we cannot compare to what happened in the past, because we have never in the history of mankind be facing a situation like this one, where we massively intervene in a pandemic with global infection prevention measures combined with mass vaccination. So we cannot compare to what we have seen with outbreaks, for example, not even pandemics, in the past. So, and also the pandemic 1918, as you know, there was no human intervention whatsoever, not pharmaceutical and not non-pharmaceutical either. So the worst thing I think that could happen is that we start vaccinating our children, because there what we will see is that the more variants we are generating, the more the less the current vaccines will match well with those S proteins on these variants. And if that happens, if we vaccinate children, their antibodies may be functional still for some time and prevent severe disease. But as I'm pointing out, these things are evolving. It's not static, it's dynamic. And when their antibodies become less functional or no longer functional, they will still be able to bind to S protein and suppress their natural antibodies. And the natural antibodies are the major arm and the major weapon of the youngsters, young and healthy children, to protect themselves against COVID. Not just against SARS-CoV-2, but basically against all coronaviruses. So another question is, Geert, you have a lot of criticism, but what do you propose as an alternative strategy? What is your scientific evidence for immune escape? So what is the scientific evidence that immune escape exists? And I think what is meant here is that, well, what is the scientific evidence that immune escape variants could be selected and could adapt to the population? So, well, all I can say is, first of all, that the conditions are fulfilled. The conditions for breeding, adapting selective immune escape variants are there. Because, as I pointed out, the more we vaccinate people, the more we will have situations where immunity is suboptimal for several different reasons. When we also consider people who have not been vaccinated but are naturally infected and asymptomatically infected, they are facing similar conditions of suboptimal immunity. And then within this population of asymptomatic people being vaccinated or non-vaccinated, well, there, of course, you have plenty of situations where the immunity is suboptimal. And so in the meantime, these people are exposed, or they are full under attack, because they are exposed, they are in this pandemic, they are exposed to sometimes relatively high infectious pressure, because the strains that are now circulating are highly infectious variants. So I think the conditions are completely fulfilled. You can even add to these people who are in a pre-symptomatic stage of the infection and also already shedding virus. And the other evidence basically for supporting, I would say, the importance of innate immunity, especially of the natural antibodies, I must say is indirect. But for example, I cannot explain why people who were protected during the first wave or the second wave then all of a sudden become vulnerable. How I don't think adaptive immunity can be an explanation for this. The only explanation I can see is that there is a suppression of their innate immunity, and I explained what the potential mechanism could be. This cannot be due to adaptive immunity. So on top, we know that coronaviruses, the common cold viruses, can give short-lived protection, for example, to people against COVID. There is some evidence of this. I don't think this is due to T-cell immunity. And we also know, for example, that NK cells seem to play a critical role in the elimination of the virus at a very early stage of infection. So that is also clearly an innate immune contributor. And so I think there is a number of reasons to believe that there is an important role of the innate immunity in protecting and eliminating the virus. And if that gets suppressed, of course, then people become more susceptible. So then, yeah, what do you propose as an alternative strategy? Well, first of all, I would say, as I already mentioned, I think it would be a major mistake to vaccinate young people, especially in view of the current situation where we have increasingly highly infectious variants that continue to grow and to propagate, and so youngsters vaccinated with the current vaccines are not going to be well protected, and I don't know for how long they could possibly be protected, but if they are no longer protected, yeah, their natural antibodies will also be suppressed, and they will not have any kind of immune defense anymore against an ever-increasing amount of highly infectious variants. So the second thing I think we need to do is that we need to protect, I guess, vaccinated people. We need to be prepared to protect them for when, for example, the antibodies would no longer be sufficiently functional. So we need to put in place a strategy to anticipate to protect these people. And then also an important thing that we could maybe look into is, we know when people have been infected by the circulating virus, that upon re-exposure, they will develop a strong immune response that will also be able to fight or to be effective against variants, provided they have been primed really with a live virus. The other way around is not true. So that means that if you're, for example, vaccinated and you then get re-exposed to the live virus, the memory that will be recalled will not be sufficient to protect against variants. So that has been nicely demonstrated in a study that we have also put on our website. So when people are infected by the virus, it would be interesting if we could establish some kind of methodology that could verify whether these people have really been primed, whether they have been developing memory B cells. Because if those are recalled due or as a consequence of a live virus infection, then there is a high likelihood, obviously, that that immune response will protect also against a number of important variants. So along the same line, I would say we may want to consider, I think we should to vaccinate young people, for example, not with the current vaccines, but with a live attenuated coronavirus vaccine. So live attenuated vaccines have been the most successful ever for eradication of polio. I know we have in the meantime shifted to IPV, inactivated polio, but the main success with poliovirus in terms of really coming close to eradication has been thanks to OPV, the oral polio vaccine, which was a live attenuated vaccine. And same, of course, applies to smallpox. It's true that these vaccines, so live vaccines, will stimulate all arms of the immune response, will probably induce a much better also B-cell memory response that upon recall, upon re-exposure to the virus, would elicit an immune response that could also cope and deal with highly infectious variants. So that is something I think we should really consider. Of course, this would not be a solution for people who have already been vaccinated with the current vaccines for the reason that I was explaining. This does not work the other way around. It's not because you got primed with your S protein from the vaccine and then re-challenged with live virus that you will recall a memory that is as good as it would be the other way around. So yeah, well, what this would do if we could vaccinate young people with, for example, a live attenuated coronavirus vaccine, we could, and people may say, yeah, but people could get ill if they are immune suppressed, etc. But I think then we can treat them. We know who has been vaccinated. If people happen to be immune suppressed, become ill, we can treat them. But at least because these people would then have a high likelihood of being able to deal with the highly infectious variants, we could start to dilute the kind of the infectious variants in the population, because the younger population would be able to deal with them, to eliminate them, because they would mount a very strong immune response also against these variants. And then we could say, well, go forth and multiply. I mean, the stronger and the more important the younger population becomes, the more we would be able to dilute these highly infectious variants, still protecting, of course, those who have previously been vaccinated. So if we now want to protect everybody with a vaccine, I think really, and I will come back to this, the only solution is the NK, would be NK cell vaccines, because the NK cell vaccines would work on a completely different principle, and there is absolutely no reason to believe that they could not protect people who have already been vaccinated with the current vaccines and then get re-exposed to a highly infectious variant. So on top, I think we should give much more consideration. It's certainly not my field of expertise, but what I hear about ivermectin, for example, and antivirals, but especially ivermectin, I think in all honesty, one needs to admit that this seems really, really very promising, and that a lot of data are available. So my only question is, can you use this in a prophylactic way? Maybe that is also going to raise the question, well, what is the likelihood that you will induce resistance? But I think we should definitely look into this. And with regard to outpatient treatment, I mean, treatment like this, because then we are no longer in a prophylactic setting, should also definitely be looked at. There is on this outpatient treatment, I think, some seminal publications, amongst others from Professor McCullough, who published in I think is the Journal of American Medicine or American Journal of Medicine, and where he's reporting about really great successes in reducing the number of people who get hospitalized by early treatment, by early treatment of people with slight first symptoms of COVID-19. So last but not least, I would say health is also important. All measures, all things that have to do with promoting health have definitely a positive impact on the innate immune system, and should certainly be part of the considerations that should be taken in order to tackle COVID-19. So people are always asking, what is the scientific evidence of all this? Well, of course, you know, there is not a clear-cut solution in the literature. It's a lot about putting pieces of the puzzle together, putting the pieces of the science together, see whether it makes sense. And then what we need, of course, is that we need to define criteria. So it's absolutely important, I guess, that we start to define criteria that tell us, for example, what is the likelihood, or how can we detect when, for example, immune escape variants start being selected and dominate in the population. What are our criteria? Is there a consensus on these criteria? What is the criteria for detecting resistance? I mean, that could be pretty much straightforward. If you have large cohorts of people who have been vaccinated twice and they still develop severe disease, for example. But also, how can we detect propagation of immune escape variants and their adaptation in the population? Do we need to look at how mutations converge to certain domains? Do we look at how curves develop as we vaccinate? We have, for example, increasing coverage rates, and despite increasing coverage rates, we still have an increase in, for example, cases of infection, etc., etc. We need to agree on those, because otherwise some people will say, well, you see an increase in infection cases, yeah, but it's still because you have not vaccinated enough people. And others will say, well, you see, I mean, when you vaccinate, you have a decrease in effectivity. So the vaccines, the mass vaccination is instead is really working. Whereas others say, no, you have an increase in infectious cases, so it's not working. So we have to define those criteria. My conclusion is that we have to solve a fundamental problem here. We need to go to the roots of this problem. What I'm seeing is the increasing complexity. And that is typical. If you cannot tackle the problem at the roots, then people start making things more complex. There is, as far as I know, for the time being, really no fundamental solution. It's just a mix of very complex measures where we combine infection prevention measures, and you have, of course, testing and tracing and isolation and lockdowns and all kinds of measures that are taken for businesses, for schools, closing them, opening them, etc. And then, of course, also we start closing our borders. There are travel restrictions, etc., etc. And what I can see is that all these measures are now increasingly answered by, especially by youngsters and by the whole population, by basically the F word. So compliance becomes increasingly difficult, and that is an important factor, that we need to take into account. So despite all this complexity, and I'm not saying that these measures don't make sense, because it's especially a problem when, for example, youngsters start to neglect all these measures, especially when now we have more infectious variants circulating. But on the other hand, we are not achieving our goals with these measures. The basic goal was to reach herd immunity, for example, with this mass vaccination. So I don't know whether anybody still believes that with this growing amount of highly infectious variants, we are going to achieve herd immunity with this mass vaccination. I cannot understand how this would be possible. And also, we have no answer as to how we will get rid of these infectious variants. As I was saying, I'm sure we will this these plateaus will not go to zero. So they are breeding grounds for the variants. And instead of getting rid of those, there is a high likelihood that we will generate even more of them. So how will can we avoid this? How will we avoid this? So nobody is giving an answer to this. And yeah, well, I just mentioned how will we get the platform, this plateau, sorry, at zero. So all this are unanswered questions, and it's not good that we don't have a perspective on those. So yeah, I think a major shortcoming has been that our criteria for managing this pandemic and also for managing and controlling, so to say, the virus and controlling success of vaccination has been the rate of hospitalization, so the hospitalization capacity. That has been the criterion for managing and controlling, whereas from an epidemiological viewpoint, this doesn't make any sense at all. So the reason, I guess, why we don't have a real solution as how we can solve this, we can go to the roots and really fundamentally solve this problem, is that we don't understand very well, we don't understand enough about the pathogenesis of this virus and how this relates to the population dynamics of the interplay between the virus and the immune system. And as long as we cannot respond to a number of questions that I've put on the website, there is a whole list of questions, of fundamental questions. I think scientists would agree that we need to respond to those questions, that those questions are critical, that they are important, and hence we have no consolidated answer to them. And I think as long as we don't have an answer to some of these fundamental questions that are very important and critical, we cannot say anything else than that this whole mass vaccination campaigns with the current vaccines flanked by all these infection prevention measures is in fact one big experiment. And that is not good. So that is why I've been begging health authorities, international health authorities, to open a scientific debate so that we can at least discuss this. And because laymen, and it should be public, I think, because laymen may not have the scientific background, but these people have a thinking brain, they have gut feeling, and I think they have a good common sense about what seems consistent, what seems inconsistent, and what seems controversial or not. So again, if one insists, if health authorities insist on mass vaccination and reject the idea that mass vaccination will breed immune escape variants that ultimately will completely resist the vaccine and compromise functional natural antibodies, then we should really agree on which scientific criteria would imply or preclude occurrence of this phenomenon. Because otherwise we are, turning around in circles all the time. So now I would say, given the current evolution and the increasing concern that more infectious variants will become dominant, I would take it even one step further and urge national health authorities, including WHO, to set up a task force centered around three different things. First of all, eradication of these strains. Really, we need to eradicate these infectious variants. The second thing is we need to concentrate on an important question, which is how do we protect the vulnerable people and how do we treat them at an early stage, so that they don't land into the hospital and to be put on ventilators, mechanical ventilators, etc. And a third important thing for this task force would be how can we promote innate immunity? So how can we promote people's innate immune response? Because I think it's a really important part of the picture, we know that there is no really a correlate of protection for this virus. And there is increasing evidence that innate immunity is important. There is also increasing evidence that several different aspects of health, of being in good health, lifestyle and healthy food and all these type of things are very, very important. And people's attention is not really drawn to that aspect, which is very important. So personally, I'm willing to help to this effort. And I'm willing to share, for example, insights into how one could possibly design an NK cell vaccine. And of course, the fact checkers will again, say that I'm making all this noise to draw the attention to a technology that I've been involved in, etc., etc. But I've learned how these fact checkers work. I've learned that whatever you do, it will always be wrong. Because either you have, for example, a patent and then we say, this guy is out there for the business. He wants to make a big business out of this. When you have not a patent on file, like is the case, for example, then they will say, well, you see, it's just words. It's not worth anything. It's not worth looking at this. So I've learned that fact checkers, in fact, they make a living out of humiliating and blaming people. And so, therefore, I don't care about them. I'm offering help, and I hope other people will offer help in their fields of specialty. And I'm calling really on all scientists, on all people involved in this, to no longer hide, because I'm under the impression that politicians hide, behind the scientists, and the scientists behind the WHO, and the WHO is maybe hiding behind their mandate, etc., etc. So I think time has come for dedicated scientists who really do the hard field work to speak up, to give their opinion on these things, and regardless of their affiliation. So we don't have the luxury anymore to hide or to keep silent, or to focus on egos, or even for nations to focus on their national interests and to focus on discriminatory policies and all these type of things. I think we have only, there is two strategies that are very, very important to fight this COVID crisis. And one, I think, is really eradication. Whether this is with drugs or with vaccines, I mean, I don't care, but we need to eradicate this thing, because otherwise we are never ever going to get rid of this, and society will just become really completely impossible in all regards. And the second thing we need is really solidarity. And I would really wish that eradication and solidarity substitute for firefighting and for animosity. And with that, I conclude, and I thank you for your attention.